Take a moment to introduce our presenters for today. First, we have Dr. Pei-Sung Lin. He is the Program Director of ITS Traffic Operations and Safety at Qatar. He obtained his master's degree from the University of Texas at Austin and doctoral degree from the University of Florida. Currently, Dr. Lin serves as chair of Intelligent Traffic Signal Operation Committee at the Institute of Transportation Engineers. He has 21 years of work experience and has published and presented numerous papers in national and international conferences. Our second presenter is Aldo Fabregas. He holds both a BS and an MS degree in industrial engineering. He is currently a research associate in the ITS Traffic Operations and Safety Program at the Center for Urban Transportation Research at USF. His work involves creation of decision support systems for transportation planning, transportation network modeling, traffic microsimulation, and transportation-related data mining. He was given numerous talks and conferences, such as the Institute of Transportation Engineers, the TRV Conference, Institute for Operations Research and the Management Sciences, and the Institute of Industrial Engineers. He has also published a textbook on discrete event simulation and several journals papers. Before I turn it over to our presenters, we have two poll questions related to our presentation today. The first one is, have you implemented a yield-to-bus program at your agency? Okay, it looks like 11 of you have not, and 5 of you have. And I'm assuming probably the others perhaps do not represent an agency. Our next question related to that one, for those of you who have not implemented a yield-to-bus program at your agency, do you plan on implementing one in the future? Okay, it looks like we have some indecision, possibly a few maybes, a few yeses and a few nos. With that in mind, I will now turn over the presentation to Dr. Pei-Sung Lin and let him take it from there.
Good afternoon, everyone. Welcome you to join our cont'd webcast. And today we're going to talk about moving the bus safely back into traffic. And especially, we're going to focus on the safety and operational assessment of yield-to-bus LED warning sign on transit buses. Before my presentation, first, we would like to give a special thanks to our participating transit agencies because their help, so we can conduct these studies. So the first one is the Hillsborough County Area Regional Transit Authority, also called HART. And the second agency is Lee County Transit, Lee Train. And the third one is Volusia County Transit, Voltran. And we really appreciate their help for this study. This slide shows you the outline of today's presentation, and we will start with the background of the yield-to-bus program. And we also going to share a little bit with you about the related studies. And after that, we'll talk about the objective of this study and what kind of test sign we used for experiments. And next, we will go through some applicable regulation about implementing the yield-to-bus LED warning signs. And next, we'll talk about how we operate the signs. And after that, we'll talk about what kind of performance measure we used for this study in order to evaluate the effectiveness of the yield-to-bus LED sign. And once we know our performance measure, and we'll talk about how we design our experiments. How do we collect the field data and how we analyze that. And we will show you the results and also talk about the behavior we observed during the field study. And finally, we will conclude this presentation and provide some recommendation for you to possibly implement LED yield bus sign in the future. First, let's talk about the background. As you may experience, or a lot of transit agency may have experienced that, is that when transit buses, when they stop at the pull-out bay, once they pick up the passenger and when they try to go back to the traffic, in a lot of occasions, they have difficulty to get into the traffic because the other vehicle on the travel lane do not yield to them. And several states have implemented yield to bus language in their statute, such as Florida, Oregon, California, Washington State, and they implement the language on their statute to enhance the safety for the bus to merge back into the traffic. And however, there's no quantitative information or the data regarding to the performance of yield to bus program or the treatment. And the data is a very important information to support the program, and we know intuitively it's very beneficial for the transit buses to pay into traffic. However, we need to have the data to support that and to justify the program and justify the funding, and I think this is very important. And so it's necessary to examine or check what kind of yield to bus treatment is effective, and what kind of countermeasure we can use to assess the effectiveness of this treatment. And there are several related studies we will share with you here. The first one is the TCRP Census 49, and this study is trying to assess the state of the practice. And basically, this study performed a comprehensive survey of many transit agencies, and the purpose is try to figure out what kind of programs implemented. Do they have any data related to, for example, the time saving or the safety benefits? They try to document those. However, from this study, they found out there is no quantitative information regarding to the time saving or safety benefits. And so that's why this particular study sponsored by FDOT is very significant on this perspective of the benefit assessments. And we also look into the guideline for the location and design of the bus stop and what's required to design a adequate bus stop. And we also look into the stop spacing, location, and design for bus rapid transit facilities. And a particular I'd like to point out here is that from this document, it mentions that when there are 400 vehicles per hour per lane, and generally that they will cause a significant delay for transit buses. And so for a 4-mile trip, accumulated delay for a bus could be 10 minutes or more. So from here you can see the importance of the program to allow the bus back into the traffic in a timely manner. So the objective of our study is try to first determine if the use of the yield to bus LED sign has any effects on the yield to bus behavior. And this is the first question we try to get answers. And the second one is, so what kind of potential effects on traffic safety by using the yield to bus LED signs? What kind of benefits, especially on traffic safety? And the next one is we also want to know what kind of operational benefits of the yield to bus LED signs. And the last objective here is we try to provide recommendation for the implementation of this yield to bus LED sign and also for a public awareness campaign for those agencies planning to implement that in the future. So this slide, we're going to show you our test sign. The first one is a decal only sign. This is as far as we know, many transit agencies use the decal to inform the driver behind the bus to yield to bus, and so this will serve as our baseline because in this study we test the other two LED yield to bus signs. And so this is the first sign we test. This is a triangular yield sign, and as you can see, it will flash and to warn the driver behind and to get their attention. And the second one is on your right side. It's a merging sign. So basically, they will show merging, and then they will show the arrow. And so this is two sides. We actually, this is one side, but here I'll show you in two different expression. Is first they show the merging on the first they show you on the top, and then they will change and alternatively. And we also need to know, in order to implement this yield to bus LED sign, what kind of regulation we need to be aware. And according to the Federal Motor Vehicle Safety Standards, number 108, chapter 301, and we highlight the regulation based on this standard. So the first one, and this is also a very important one, is yield to bus LED sign. You can install that on the bus as aftermarket equipment. And so basically, you will not ask for manufacturer to have this, as a whole new bus and with this installed. Currently, it's not allowed. So basically, it's as aftermarket equipment by bus owners without the assistance of a manufacturer or distributor or dealer. And the second is that the sign can be wired to flash, and if done in conjunction with the regulatory turning lamps, such as when you turn out your right turn signals or the left turn signals, and this LED sign can flash along with the turn signals. And the next one is that this yield to bus LED sign cannot impair the effectiveness of any regulatory lamp, because the purpose of this is try to inform our driver behind the bus, and so basically we cannot affect or reduce the effectiveness of other regulatory signals. And the last one is the sign should comply with the local regulation to see where regarding the color or the configuration and how you're going to install that in your vehicle, the transit buses. And here we'll show you how the yield to bus LED sign, how do they operate. And as you can see that at the beginning, when you see one here, when the bus is approaching the pull-out bay, and there's no signal, any turn signal on yet. But then when they approach it very close to the bus bay, the right turn signal will be turned on, and then bus continue to move into the bus bay. The right turn signal is continue, and as you can see, the the stop light of the vehicle, the bus, will be also turned on because the vehicle is going to stop, and the tail light is on too. And then when bus at the location to stop and to pick up the passengers, the stop sign is the stop signal is on behind the rear. The stop signal is on, and the tail signal is on. After the bus pick up the passengers and they start to merge, and at that time the bus driver will turn on the left turn signal, and at this time the yellow signal will be turned on too. And there are two ways to do that. We'll talk about a little bit later. And so after the vehicle finish the maneuver of merging back into the traffic, then all the signal will be turned off. And so this is the sequence of the yellow to bus sign operations. And there are two ways to activate the sign. And the first one is based on the timer. We call timer mode. And so basically, the driver can activate the left turn signal, and then he or she can push the yellow signal activation button, and then the indication lamp will illuminate and showing that the yellow signal is flashing. And so basically the driver behind the bus will see that. And the yellow signal will turn off after 10 seconds. So it's a timer mode. It will turn on, and then it will stay for 10 seconds. And the second way to do that is a switch mode. If we set up in that way, and the driver can activate the left turn signals, and he or she will push the yellow signal activation button, and while try to merge back into the traffic. And when the switch is released, the yellow sign will be turned off. So basically, the driver, after he or she finish the merging, and he or she need to turn off the yellow to bus signal, and then in order to terminate the yellow sign operation. And so with those information, next we're going to talk about the performance measure. So how will we be able to evaluate the effectiveness of the yellow to bus LED sign? And here, first is we try to compare the yellow to bus behavior. And as you can see here, we have on the table here, as you can see, we divide that to 3 different categories. The first behavior is yellow to bus behavior. So if the vehicle in the adjacent lane shows slow down or stop, or the people behind the bus, they stop to wait for the bus to back into the traffic, and it's a yellow behavior. And the second behavior we're going to observe is that in some cases, there's other travel lane, and the bus driver will change the lanes and to allow the transit bus to back into the traffic. And this is another behavior we frequently see in the field. And the third behavior we can see is the gap. We call this gap. Is that the vehicle on the travel lane, they do not yield to bus, and the bus driver needs to find a gap in order to merge to the traffic. And on the bottom here is the re-entry time. We try to evaluate whether when we use the yellow to bus LED sign, can we save the travel time of the bus. And so we try to compare if we use only LED decal, and how much time for the bus to merge. And we'll compare that the re-entry time to rows if we use the LED yellow to bus sign. We try to compare the difference and to see where this LED sign is effective. And then the next performance measure is traffic conflicts. Because for this study, first we want to observe the behavior, but at the same time, we also want to make sure if the yellow to bus LED sign if effective, but they do not introduce new conflicts. So we also want to look at the traffic conflicts. And here we divide the conflict into the 5 different categories. The first one is car. As you can, let me see, I can. Okay, the first one is that as you can see, the diagram here is car and merging buses, and so when buses try to merge and the car is they compete on the same travel lane here, and this is the first conflict we can see, and the second one is the car and the accelerating buses. When bus accelerates to the travel lane, and the car behind have to really brake in order to avoid a crash, and this is a potential conflict. And the third conflict is that when the buses try to merge back into the traffic, and the red vehicle here behind the bus try to change lanes, and as you can see, there's a conflict between the red car and the blue car, because they try to compete the same space there. And the next conflict is the cut-in car and the car. So basically, the red car cut in before this blue car, and the blue car have to slow down to avoid a crash, and there's a potential conflict here. And the last conflict we have identified here is that the blue car here, as you can see, the blue car slow down or stop to let the bus in. However, the red car behind the blue car may not expect that, and so the red car have to brake hard in order to avoid a crash with the blue car. So basically this is the 5 different conflicts identified here, and when we do the field data collection, we also collect this information. And from here on, we're going to talk about the experiment of our study, and how we collect those performance measures, how do we perform this study. And I will turn this back to Aldo, and he is going to show you how do we conduct the study in detail, and also he will show you the results and our analysis. So Aldo?
Good afternoon, everyone. Here we have the experimental setting to collect the data. We to prove or to verify the effectiveness of the different yield to the bus LED signs. Well, first of all, we have to look, and the first thing is, okay, how do we measure if the vehicle yielded or not to the bus? Then for that we need a camera looking back into the behind the bus, the traffic behind the bus, and so we partner with agencies, and they we were able to talk with the technical teams to be able to install a camera, as you can see in here, looking back into the traffic. Here's another this is a sample in Hardline, and here you can see one of the test signs. Leadtrend here, they had they had the little one, the triangular sign, so we just replaced the sign for the big one to perform the tests. And with this camera, we were able to look at yield to the bus, measure the reentry time. Well, the reentry time was measured with the front camera, and also with the rear view camera, we were able to check the number of conflicts, to count the conflicts. Here we have the different corridors in which we tested the LED signs. In Tampa, we have a 2-lane corridor, 1 lane each direction, and in Nebraska Avenue, it's a urban minor arterial. In Fort Myers, was our second site. We had a 6-lane corridor, 3-lane each direction. And in Daytona Beach, we have a 4-lane corridor, so 2 lanes each direction. And so we have 1, 2, and 3 lanes. Not quite the same traffic conditions, of course, but try to have some sort of experimental order there to assess the effectiveness of the sign. Here's some observed conflicts, from our previous. We first defined the possible conflicts that we can encounter in the field, and then we explore all the video data for the data collection period. Observing these conflicts are defined when there was a close call or a maneuver that involves braking a little bit harder than normal because the vehicles were too close. So we consider that as a conflict. And here is the bus merging and a vehicle just trying to squeeze in the bus lane. And here this is a 1 lane each direction. So in this situation, there was a lot of conflicts because, of course, the bus to merge back into traffic has to actually block not block, but it has to go and merge in the only travel lane. So by itself, just a single lane here, it brings a lot of potential for more conflicts. So that's the first scenario. Also in this scenario, we didn't see a lot of these conflicts, just maybe a couple. But here's a sample of this type of conflict that a vehicle was trying to cut in to pass the bus, and there was a vehicle behind, and so they presented that type of conflict. We also observed, good behavior. This is, and it's important to know that yield is not stop. Yield is just reduce the speed. So they just have to slow down a little bit to allow the bus to merge back. But this is so the advantage of the sign is that the bus can let the drivers behind. They can know the drivers behind in advance that they're going to merge back, so they can actually slow down well in advance of the bus stop, as in these cases where the vehicle is slowed down and there was no conflicts and it was just letting the bus back in safely, because the distance of the fall is safe enough. In some other cases, vehicles were able to spot the bus from even farther away and actually give enough space, because the gap for the buses to merge back in traffic is significantly larger than the gaps for just any other vehicle. So they need this type of gap, like a long way in advance, when the traffic really slow down and allow them to merge back in. Okay, and out of that, we had to crunch some numbers because we had to prove that to support that there's an effect for implementing these treatments. So we went ahead and count the number of maneuvers with traffic, and which of these maneuvers ended up in a yield, up in let's say no yield, or the bus waiting for a gap in traffic to merge back. So in this chart here, we have the dark portion of each bar is the percentage of maneuvers that where they were no yield, so the bus has to wait for a gap to merge back in traffic, and the green portion, the upper portion is the green, is the percentage of maneuvers that ended in a yield, and the gray area in the middle, sometimes when it's allowed, it's a safe lane change from from a distance, when the traffic behind the bus safely changed lanes to allow the bus back in. And in the chart, that's the percentages of maneuvers, and here we have for the three different sites. Tampa is a one-lane corridor. Fort Myers is a three-lane corridor. Daytona Beach is a two-lane corridor. Four-lane corridor, two-lane each direction, and same for Myers, six-lane each direction corridor, three lanes each direction. And and here we have another division, which is the treatment. This is decal only, our baseline treatment, and this is the implementation of the merging sign, the big one. And this is the triangular sign. For example, in Tampa, there was 40 with the decal only. We observed 41% of the maneuvers that we observed ended up in a yield. When we implemented the merging sign, we observed that 78 or something, so maneuvers ended up in yield. So it was a significant increase in the yield, or a significant decrease in the no yield behavior. So in the Fort Myers corridor, we have more space to allow the traffic to change lanes. This one, it was a one-lane corridor, so therefore there was no lane changes. In the others, we can see the trend that with the decal only, we have more no yields, and when we implement any of the flashing signs, the no yields were reduced, so the yield portion was increased, and the effect can be observed that is probably better. I mean, significantly better in one lane each direction. When we have two lanes, still significant, and with the three lanes, because the vehicles have more space to maneuver, or there may be it's different characteristic, but then there's a still improvement, but the impact of the improvement is a little bit less. Now, in terms of
Hi, everyone. We apologize. It sounds like Aldo may have lost his audio just for a few moments, so thanks for your patience while we try to get him back online.
Hello.
Great. Go ahead.
Okay. Solve some technical difficulties here. Okay, let's go back online. Okay. In the next slide, we can see the result of a comparison in the Fort Myers area, where we have, okay, which sign, for example, may be better than other. We find there's no difference between the two different signs, either the triangular or the big merging sign. They are their performance is equivalent as compared to the decal only treatment. The same applies to the Daytona Beach scenario, where we were able to compare all the 3 different treatments, and we see that they are significantly different than the decal-only treatment. These are statistical tests to justify that there's evidence of the difference in performance for the different signs. For the safety performance measures, we analyze the number of maneuvers with no conflicts, and then we have the rest of maneuvers with conflict. For each maneuver, we define just there's one dominant conflict that was presented there, and we see, of course, more conflicts in a single lane each direction, because naturally the cars behind the bus, the vehicles behind the bus, they have no much room to maneuver, so naturally this leads to more conflict. But with the emergent sign, or when the LED sign, these conflicts were reduced, and basically the bus operator was able to signal properly to the traffic behind the bus that it was the intention to merge. So the vehicles behind were slowing down at an appropriate distance, allowing the bus to merge back in. Same with Fort Myers and Daytona Beach, and again, the improvements are somehow related to the number of lanes. When the one lane each direction had most improvement. With the 2 lanes each direction, also we have kind of the second place in improvements, and with 3 lanes, it's pretty much the same. It's statistically equivalent. So in this case, the use of LED signs basically either is equivalent or improves the safety for the existing merging operations or merging maneuvers. Here is another performance measure, which is the re-entry delay, as defined in the previous slides. And in a single lane corridor, is probably the most where most impacts are obtained, and we have about 2-second improvement. And of course, there was a traffic. I mean, this measure is a little bit difficult to obtain because there was no, not all the bus stops have the same delineation, reference points, and traffic conditions behind the bus are different. So there are many factors involved in this one, but we could see that there was some improvement. Also, this is in the case of Fort Myers in the 6-lane corridor. We see that the decal-only treatment, we have several like outliers or extreme points, whereas with the use of the other signs, even though the average is pretty much in the same spot, and the decal only tends to be a little bit higher, but not significantly higher to say that this is statistically different. But the number of outliers at least is reduced, and a little bit of so that what we observe is that when they have long queues and the bus is trying, like at the PM peak hour, and the bus trying to merge back, the use of LED signs helped to signal, and so people can actually let the bus back into long lines. Same can be probably observed in the corridor in Daytona Beach. So there was a reduction in the mean too, and a little bit on the variance too. So cannot be really that conclusive on this aspect. I mean, there are many, let's say, factors in this, but overall, it tends to help improve these conditions. Now, was they significant? Well, yes. We went ahead and performed some sort of statistical tests to justify, to prove, to have the research component to these type of studies, and for all of them, we asked the question: are these LED significant? So our hypothesis was: the use of LED has no effect, or do they have effect? So and the answer is that yes, it has effect. So for many of these statistical hypotheses, same as for the case of safety. Are there any significant effects for the number of conflicts? And yes, there's a significant effect, and actually it was reduced for the case of one-lane corridor. Of course, this is very specific for example, the Tampa corridor, but with more data, if more data becomes available, we could gladly analyze or continue to look into this type of problem. But for our test, it showed that it was favorable in reducing the number of conflicts. Same can be said for Fort Myers case, which is a three-lane each direction. Either it was improved or maintained as compared to the decal treatment. And for the Daytona Beach, also there were. This is the results. It's pretty much put it in numbers what we saw in the charts, and in this case, yes, there was an improvement in the yielding behavior. There was improvement in the percentage of maneuvers presenting at any traffic conflicts, and there was somehow numerically there was a reduction, but it was not significant. But it tends to help in the reentry time. But notice that this is reentry time is measuring only in a per, let's say, per bus stop. So it has to be in the order of seconds, just a few seconds. Here, from this point on, I think we have to. I'll turn the presentation back to Dr. Lin to finalize with lessons learned and conclusions.
Stand by 1 second. We'll have Dr. Lin back with you in a moment.
Okay. Sorry, I think I need to turn the speaker on. Okay. So from this, we done several things from this study based on the interview and with different transit agencies, and also from the study and as well as talking to transit drivers. And so first is that in order to implement the yield to bus law, and it's very important to have a well-coordinated public information campaigns, and we need to have all the related agency all work together. And second lesson we learned is that we cannot just do campaign one time, and we need to do the campaign constantly, for example, every 6 months, and we need to have certain type of campaign on the Yield to Pass program. And the third lesson we learned is that we need to, the flashing sign, like the one we are just doing, the yield LED sign, and it need to be placed high enough so the people, the driver behind the bus still can see it, and we need to make sure the vehicle just behind the bus will not block the LED signs. And the next lesson we learned is that based on the experience we have with the transit agencies, and when they implement this, some agency, they already implement yield-to bus LED sign, and also during the study, and we didn't notice anybody have any problem or any crash related to the implement of this particular yield-to bus LED sign. And the next one is that here we mentioned the lack of information measure is if we don't have enough data to support that, sometimes it may the transit agency may lose the funding to continue the program, especially when economy is in current condition. It's not. It's a big part, and so in this case, it's especially important that we do have a data to support the program and to show its effectiveness. And here, this is the public education, and this is the picture we have from the TriMet Oregon, and they did a great job and to implement the yield-to-bus program, and they used the yield-to-bus LED sign, and this is a campaign they put behind the bus and show it very clear. So all the driver behind the bus will see this and know that. And finally, we'll come to the conclusion, and here is several selected conclusions. And so the first is that based on this study shows that there is statistically evidence that the yield-to-bus LED sign will have a positive effect on the yield-to-bus behavior, as the one Aldo showed earlier. And the second one is that the yield-to-bus LED sign can improve the yield-to-bus behavior without introduce new traffic conflicts. And it not only not introduce new traffic conflict, but it also, as you can see earlier, our results, the results show that they can reduce the traffic conflicts. And the third conclusion here is that we try to provide you the quantitative number, and based on the study, the data we collect and analysis, we found out that the yield behavior increased by 14 to 34% based on the study compared to use only decay only. And so this is quite significant. And the next conclusion is that, as Aldo mentioned, you can see that the safety and operational benefits is more on the 2-lane or 4-lane corridor. For 6 lanes, and the magnitude of the impact is reduced because the vehicle have a chance to change lanes. And so the benefit is reduced a little bit. And the next conclusion is that implementation of this yield-to-bus sign, LED sign, on transit bus can help the bus merge back into the traffic safely. And the next one is for the sign design. We recommend that it should be consistent. So when we implement the triangular sign, you probably want to implement the triangular sign on all the buses. So the driver will become familiar with the sign, so they know when they see LED sign, and they know what does that mean. And another recommendation here is that earlier we mentioned there are 2 ways to activate the yield-to-bus LED sign, and manually or automatically. And here, for the manual activation, we recommend to provide a different handle, and not only in color, but also in texture and size. So that will help the transit driver to distinguish and make sure they activate properly. And the last recommendation here is we should link the activation of the yield bus handle to operation to the left-hand signal. And so if we do that automatically, you probably can go through either the GPS, global position system, or we can program that, and in certain condition, and it will trigger the handle, the button, and to show that automatically. And so this it really depends on the preference of agency, and then it can be achieved. I think this will be our presentation today, and we appreciate your participation, and we also like to appreciate FDOT, and because Amy Dates, our project manager in DOT, she is strongly support the Yield Bus program, and so I think we appreciate her guidance on this project. Chrissy?
Yes, thank you, Dr. Lin. At this time, we'd like to open up the floor for questions or comments. You can see here on the top right-hand side of on top left-hand side of your screen, you can click on QA. You'll type your question into the box and click Ask. And as we receive questions, we will go ahead and ask them. Looks like we have one question here. Did you do any public educational campaigns?
For this study, we do not do particular public education campaign. And this study, basically, we try to know that try to compare the effectiveness or the difference using just decay only, or and LED yield bus sign. We try to see what's the difference. So we did not conduct public education. So if we can do the public education, and then along with implementation of LED sign, we believe the results will be even better.
All right, thank you. Looks like we have one question here. If an agency is interested in implementing a yield-to-bus LED program, how will they be able to evaluate its effectiveness?
That's a very good question. For the agency, if they are interested in to implement that, and I think we will have some recommendation for them to easy to get the data to compare. And so one way to do that is they can also survey the transit drivers and to see how do they feel about use this yield-to-bus LED sign. Another way to do that is they can collect some question information and to see what's the difference. And the third one is that the agency also can collect the travel time for the bus from certain location to the destination, and to see is any difference, because currently I think almost all agencies have the APC system or the AVL system on the bus, and they will tell you when the bus stop and what's the time at that particular bus stop. And so based on those information, and the agency will be able to see if they use the LED yield-to-bus sign, and if they can collect those travel time on the route and compare the one without, and to see whether it's improved or not.
All right, thank you, Dr. Lin. We have another question that came in. Did you consider possible increases in collisions with pedestrians in the bus stop?
Yeah, I think that's a very good question, and definitely this is the one we are very interested in to study. And for this particular study, we do not collect that type of information. However, I think we're going to conduct a future study also related to VO2 bus and treatment, and we'll more focus on the sign, on the roadway sign or the pavement marking, and as well as other potential treatment. And I think we'll definitely try to collect more information on that, and hopefully by that time we can be able to share more with you.
Okay, thank you. Also, Dr. Lin, I have a question from one of our participants from outside of the United States. In one of the slides early in the presentation, there was a reference in a table to tail. Is this the stop sign on the rear of the bus, and how does this operate?
You mean the tail light?
Yes, I believe that's what it was.
Yeah, when bus is approaching and start to stop, and it will trigger their brake light and the tail light to be on. So they will be on at the same time. So it's not like they particularly trigger when they brake, and the brake lights and the tail light will be on. Also, you got anything to add?
No, I don't think so.
Okay.
Looks like our last question here is where can we find the final report?
I believe the final report, if they, I think I know it's in our cont'd website, our program website homepage. And Eldo, are you aware is any place they can find it? I think we can send the link. I think DOT probably also put on their website too, in some publications. And I think we can provide a link to whoever is interested to the final report. Any other questions?
Okay, well, I think that concludes our questions for now. We'd like to thank everybody for joining us today for our webcast. Dr. Lin, did you have anything else to add before we conclude?
No, I just appreciate everybody participated, and if you have any suggestions or comments regarding to our study or future plan, just let us know, and we'd like to work with you and listen to you. And so when we conduct the next study, we can put more into our consideration on our study. And thank you very much.
Thank you. And for those of you in the webinar, if you would please take a moment to fill out our survey, we would appreciate it. And we look forward to seeing you at our next webcast. Thank you.